Hi everyone, welcome to our video on using Venn diagrams to find probabilities. So in this section, or in this part, we're using the principles that we had with Venn diagrams with cardinal numbers and just applying it to probability. So instead of whole numbers, we usually have these types of decimals. And then these rules can also always help. So the complement rule especially, I think, but that's our union rule that we've seen before also. Okay, anyway, let's show how this works. So we've got, one other thing that I didn't say, the sum of all the regions of the Venn diagram will always be 1. Okay, so because that would be all of the different probabilities added up. Okay, so as soon as you see stuff like this, when it's just random probabilities given, it's the good idea to go ahead and make your Venn diagram rectangle, give yourself plenty of space, and then I see 2 letters. Okay, so I would have 2 circles drawn out. There's my A, there's my B, so that's my universe. And then we're taking the same strategy that we had from back when we were doing cardinal numbers. I'm just going to look at these things and see if I can use it. So for instance, the probability of A equaling 0.55 means that these 2 regions of A need to add up to be 0.55. Okay, since I can't use those right now, well, then I need to move on. The probability of not B is 0.7. So that means the crescent shape here in A and the complete outside need to add up to 0.7. So I can't use that either right now because I have 2 regions that would be blank. And then the probability that A or B is 0.72, well, A or B is the 3 regions here inside all the circles, so the 1, 2, 3 regions. That needs to add up to 0.72, so that means I can't use that either. Okay, so that means they're telling us we have some information that they didn't give us that we need to figure out first. Here's where we can instantly use the complement rule right on this one. This tells us, and we could do it with A as well, but this tells us right away if the probability of not B is 0.7, that means the probability of B must be 0.3. Okay, so it's like, so just to use a example in words here, like if the probability that it will not rain is 0.7, the probability that it would rain would be 0.3. Okay, so that's all we're doing to break it down. And similar, so the probability of A is 0.55. That means instantly the probability of not A would be 0.45. Okay, so the probability of something plus the probability of it not happening should add up to 1. Okay, so that's what we're doing in both those cases. But now that I've written those out, I'm going to take our probability of A and our probability of B and the union and use my union rule. Okay, so let's do that right to the side on this problem. So the probability of A union B is the probability of A plus the probability of B minus their intersection. Okay, so we've got A and B like that. So I want to set that up too. Okay, and one of the reasons that I kind of like to do that is just to be able to see if I have everything, and we do. We have the 0.72 equals, let's use the probability of A, the 0.55, plus the probability of B, that was the one that we found, that was in the hidden information, so 0.3, and then minus the intersection. And then once we get that intersection, things are going to be real good for us. Okay, so careful of your addition here. I need to move it over a little bit. So 0.72 would equal 0.85 minus that intersection, which I'm going to squeeze in there. And then when we minus the 0.85 over, it would give us negative 0.13. And that would equal the negative probability of the intersection. And so the 2 negatives would cancel. And we would have the intersection is 0.13. So sometimes we have to do a little bit more preliminary work on these problems, but we got it. Okay, and that's great because that's what's going to go right in there. Remember, the football shape is the intersection between A and B. Okay, so we have the football shape done. All right, and then now I can go through any of these ones. Okay, so that was our, I guess the real first step was finding these secret ones based on the complement rule. And then our second step was all right there. So that was the 0.13. And then let me use a different color to fill in the rest. Okay, so now that I have that inner part, I'm going to go ahead and use the probability of A and the probability of B. I guess that's number 3, sorry. Our third step, so I can fill in their individual crescent shapes. Okay, so if the probability of A is 0.55, in the middle I already have 0.13 accounted for, so I have to just do a little bit of subtraction, and we would get 0.42 would be the leftover probability in this crescent shape, because 0.42 plus 0.13 is 0.55. And then for the probability of B, it's saying that it needs to add up to be 0.3. I already have 0.13 in there, so that means I would need 0.17 as my leftover, because these two add up to be 0.3. Okay, and then the last thing I need to do, well, I do have 4 regions completely in this whole thing. I have 3 of them filled in. Notice that those should add up to be 0.72 as well. Okay, so if we add these up, notice it does add up to 0.72. Well, the most outside part, so this outside part, I'm just going to mark it in blue. Let's say this is step 4, would be 1 minus these inner probabilities. So minus those added up. Oops, one more. Not the parenthesis yet. Which is something that we also have kind of a way to check. It should be 0.72, and when we do add it up, it is 0.72. And so from there, then we do get 0.28 left over for our final probability. And notice we really could have done this, messed with this first to get the complete outside. Okay, so there's different ways to break it down. And then from there, we maybe could have figured out some of the other stuff involved with it. Okay, so for instance, just to highlight, ooh, that's not highlight. Just to highlight, like if we had used this information first to get that 0.28, then we could have used the probability of not B being 0.7, because this 0.42, which we would have found, plus the 0.28 does add up to 0.7. Okay, so you can go back and recycle some of the stuff in here to really verify all of the numbers are correct. Okay, so but this is the main goal, and then now we have to go back and just kind of remember how these Venn diagrams would look. Okay, so the probability of not A and not B. Okay, so I'm gonna squeeze my diagram in here. Okay, so that's a little smaller than I probably really want, but let's go ahead and I think it will work. So I would give myself more space, but on a real problem, on a test problem. But here I'm just kind of squeezing in more problems than maybe I need. All right, but here we go. So not A and not B. Okay, so not A would be this region and this region in the purple. Not B, let's do it in the green. Not B would be this region and this region. Okay, so the crescent shape of A and the complete outside. The AND symbol, putting these together, would be where the two colors or two symbols in my picture are matching, which would be the complete outside. Okay, so the probability of not A happening and not B happening is the 0.28. All right, there we go. Okay, so that's how these problems kind of work. Again, just like those cardinal number diagrams. And if you're unfamiliar with those, say you went straight to these probability videos, it might be worthwhile to go back and check those cardinal number Venn diagrams, which are in a different video, and it shows how to those ones get broken down, which can really help with this. All right, so this next one, again, I would have my A, I'd have my B. Okay, so we got those, and I'm going to use the same type of markings. Okay, so not A would be, well, it's the same as before, I guess, with the markings. Not A are those two regions. Not B would be these two regions. Or is telling you include any region that is marked. So that would be this crescent shape, that crescent shape, and the whole outside. So the only part that wouldn't be shaded is the football shape. Okay, so the football shape is the final probability that's desired for this probability. It is 0.13. All right, there's one of them. There's another one. Okay, so let's get these other two. Okay, so again, I'm going to draw my Venn diagram to see where I have the important regions. There's my A and B again. Okay, so not A. Okay, so not A still is that crescent shape and all the outside. B is, well, the two regions that make up B. And then or, like before, is any region that is marked. So the inner region, the crescent shape of B, and the complete outside. Okay, so it's like the crescent shape of A is what's left out. So our probability then, I'm going to use addition and just say it is the 0.42 plus the 0.13 plus the 0.28. Okay, so oh, no, I was looking at it wrong. Okay, oops, sorry. Let's go back. Okay, so I wrote the one that was not shaded. That's the ones that are shaded, all of them are included. So the 0.13 plus the 0.17 plus the complete outside is the 0.28. And then from there, we could add it up, and it would give us 0.58. Just like that. Okay, and thinking, okay, so going back, actually, okay, so some red flags maybe been raised on this last one. I was going too quick on this and losing track of what I was doing. I wrote the 0.13. That was the one, so I said the one region that is not was the one that I wrote as the answer, but this is not the answer. The union symbol is all of them, so sorry about that. I could have used this answer. Okay, so let's go back. I could have used that answer and done 1 minus the one region that was not shaded. Okay, so that's what I was thinking when I wrote down the 0.13, and I just recognized it just now, which gives us 0.87. That's the correct answer. Or I could have added all of the regions that were shaded, the 0.42 plus the 0.17 plus the outside is 0.28. And then when we do add those up, it would be 0.87. So it's a way to check it too. Okay, so same answer. It's kind of got lost a little bit. Okay, so sorry about that. So I meant to do the 0.13. I wanted to use that, but I didn't mean to box it that soon. 1 minus the 0.13 was the final answer. Okay, so sometimes I make mistakes too, and I'm leaving that in there to show I make mistakes. As long as we catch them, we're good, right? Okay, or if I ever do something like that, you can always, and if I don't catch it, you could always question me. Okay, so anyway, so it happens to everyone. So one more, though, with this diagram. So we have A and not B. All right, so I'm going to use my color technique again. So A would be the two regions that make up A. Not B are the regions outside of B, so right here and right here. The and symbol is where they're overlapping. So the one crescent shape of A is all I want, which is the 0.42. Okay, so this 0.42. There they are. Okay, so these can be kind of lengthy problems. Just take your time with it. Okay, so especially if they ask for all sorts of extra stuff. Okay, and they can ask lots of random things on it. This is the key, though. Get this main thing going, and then break down each individual diagram the best you can. Okay, other than that, I think that's a good time to pause. Let's try this one out in a different video. So it's got a word problem style, but we'll see how it works in a similar fashion. Okay, so thanks for watching, and please let me know if you have any questions.